Getting salty with Cilsick.
Hey everyone, and welcome to another episode. Today I'm coming to you from Lackawanna County in Pennsylvania in the Poconos, and I want to talk about coal. Really what I want to talk about is continental drift and the evidence that supports this theory that was derived by a man by the name of Alfred Wegener. Now, if you look around me, I am literally standing on a pile of coal. Take a look here. This is all a type of coal called lignite. Not very valuable in terms of combustibility and energy content. Only about 25% true carbon coal. But this is a great spot to talk about continental drift. Now, we all know a little bit about continental drift, the idea that the continents once fit together like pieces of a puzzle. We definitely see this evidence from looking at how South America and Africa seem to fit together. But there's other evidence, other critical pieces of evidence that Alfred Wegener talked about in this famous theory. One is that at one time, all the continents had come together to form a supercontinent called Pangaea. Then sometime after it formed, it started to break apart. When it was together, there were contiguous mountain ranges that went down from one continental plate to another, all lined up together. But once the continents broke up and spread apart to their current configuration, now they're, on opposite sides of ocean basins, but when you put them back together again, they all line up. Another important piece of evidence that supports continental drift is the fossil record. Back when Pangaea was together, one supercontinent surrounded by a super ocean called Panthalassa, there were organisms living and thriving that are now extinct. Their fossils can be found, and we can find fossils of species of the same species on the east coast of South America and the west coast of Africa. These species were not aquatic. They couldn't swim across the ocean back and forth. They were land species. So this supports that at one time, there was no ocean there, the Atlantic, and it was one contiguous piece of land that these extinct animals lived and thrived on. But the big piece of evidence that I want to talk about is coal. Now, if we go back in time about 360 million years before Pangaea even came together, that was kind of the start of the Carboniferous period in our geological past, from about 360 to 300 million years ago. This is a time period where the land that we're standing on now, here in the Pocono Mountains, was a flat, almost tropical, swampy area. And during this time period, there was lots of primary production going on, lots of plant biomass being produced and dropping to the ground and building up in thick layers. In fact, it was building up so quick that decomposition by bacteria could not occur fast enough. Over time, these layers would get buried deeper and deeper in the geological strata. And because of that pressure, a lot of the oxygen was pushed out of this material, creating very, very dense carbon compounds. Over millions of years, with increased temperature and pressure, this is where coal is formed. We have these thick layers about 300 million years ago that aren't quite coal yet. They're not coal yet, but they're still in the process of becoming coal. Pangaea came together. For 100 million years or so, these layers are buried. They're undergoing these processes to become coal. And then about 200 million years ago, everything split apart and started moving, all the continents. Eventually, today, we have this area of Pennsylvania is located on the planet, on the globe, in an area where coal could not be formed. So again, this is the kind of evidence that supports that the continents were once drifting around and moving around on the surface of the earth. Because once this area right here was in a much warmer, tropical area, the ecosystems were very swamp-like and very flat, very different than what we see today. Now you might ask, how did these mountains form? That's the last little tidbit I'll share with you. They formed about 300 million years ago when the continents came together to form Pangaea. So during that process, plates came together collided into each other, causing this uplift of mountains, so that we have these Appalachian Mountains. And right now we're kind of at the northern end of the Appalachian coal seams that are found all down the Appalachian Mountains. Earlier I mentioned Alfred Wegener. He's the man that we give credit to for coming up with the theory of continental drift. He was a meteorologist by education, not a geologist. So when he announced this theory and the evidence that he included with it, a lot of the geologists at the time didn't really give him credit or believe in what he was saying. The main reason was that they asked him a simple question. Okay, we understand your theory, but how? What is the mechanism that moves these giant pieces of the Earth's surface? And he basically said, I have no idea. Maybe it's the gravitational pull of the moon that causes the tides also pushes these plates around. So he wasn't sure, and he couldn't answer that question. So therefore his theory was pretty much forgotten for many years. Earlier I mentioned that all of this pile of rocks that I'm standing on, walking on, literally I'm standing on a pile of coal. This is lignite, and it doesn't have a huge economic value due to its low carbon content. This right here is a piece of anthracite. This, or black coal as they call it, where lignite is often referred to as brown coal. This is the type of coal that was mined, sold, and burned. This is the type of coal that has some value to it. So why is all this coal, why is this big pile out here just sitting here and not being collected and sold? Because it doesn't have the economic value. Where this type, which is very few of it out here, does have a value. All this was mined out of the ground below me, and this other stuff was just, you know, bycatch almost, we can call it. Wasn't needed, but had to be removed to get to the good stuff. So a little bit about coal and how coal supports the theory of the theory of continental drift. Hope you enjoyed it, and thanks for watching.